So now let's look at practice problem 2. 1 mole of a monatomic ideal gas in the initial state T is equal to 273 Kelvin and P is equal to 1 atm is subjected to the following 3 processes, each of which is conducted reversibly. 1. A doubling of its volume at constant pressure, then a doubling of its pressure at constant volume, then a return to the initial state along the path P is equal to 6.643 times 10 to the negative 4 V squared plus 0.667. Now we calculate for the heat and work effects which occur during each of the processes. Cp is equal to 2.5 R. So first, let's look for the state variables of state 1 or our initial state. So initial state natin, you have pressure 1 atm and temperature 273 Kelvin. We know that there's only 1 mole of the substance. So to get for volume, PV is equal to nRT or V is equal to RT over P. N. And since N is 1, that's just mawala siya. It's equal to 0.08206 times temperature 273 Kelvin over 1 atm. And volume 1 is equal to 22.4 liters. Then from state 1 to state 2, we know that the pressure is constant but the volume is doubled. So 22.4 times 2, it is 44.8 liters. To get the temperature for this one, PV is equal to nRT or T is equal to PV over nR. Pressure 2 is 1 atm. So T2, V2, P2. V2 is 44.8 liters. And R is again 0.08206 multiplied by 1 again. And we get temperature is just double of 273, which is 546 Kelvin. Now for state 3, we know that we doubled the pressure, 2 atm, but the volume is constant, 44.8 liters. Then getting for the temperature, T3 is equal to P3 V3 over R, and is equal to 2 times 44.8 times 0.08206. This is equal to 546 times 2, 1092 Kelvin. So to make our calculations more accessible or mas madali, what I prefer is I draw the PV diagram, because to calculate for the work effects, we just get the volume under our process. So ang state 1 natin is at pressure of 1 atm and at volume of 22.4 liters. We can put it here. From going from state 1 to state 2, it has the same pressure but it doubles in volume, 44.8. And from state 2 to state 3, it doubles in pressure but constant volume. So this is state 1, state 2, and state 3. So sabihin natin ito yung 2. Then it will go back to state 3 by a path defined there. And this path is P is equal to 6.643 times 10 to the negative 4 V squared plus 0.6667. So our pressure volume diagram would look something like this. So now let's look for the different heat and work effects for each of the process. Let's start with from state 1 to state 2. This is your first process, a doubling of its volume at constant pressure. Since your volume is doubled, this is at constant pressure, this is called an isobaric process. And we know for an isobaric process, the work is just equal to P times V2 minus V1. This is equal to 1 times 44.8 minus 22.4 liters. This is atm. And this is equal to 22.4 liter atmosphere. Ang conversion natin from liter atmosphere to mole Kelvin 1 liter atmosphere is equal to, ang liter atmosphere to joules is 101.325 joules. So this would be equal to 2,270 joules. So that is for work. Delta U is equal to NCV delta T. N is the number of moles, which is 1. CV is equal to 1.5 R. Since 2.5 R si CP, CV is 1.5 R. 1.5 times 8.314. And delta T is 546 minus 273. And we'll get that delta U is equal to 3,405 joules. So, bakit natin kinuha si delta U? Because we know that delta U is equal to Q minus W, which will mean Q is equal to delta U plus W, or 3,405 plus 2,270, which is equal to 5,675 joules. Now, let's look from B, from 2 to 3. This is a doubling of the pressure at constant volume. So, this is a isobaric process. Pag isobaric yung process natin, we know that work is equal to 0. This will mean that delta U is equal to Q. And delta U is just equal to N CV delta T. It's equal to CV is 1.5 times 8.314. Delta T is 1,092 minus 546. This will be equal to 6,809 joules. So this work is 0, and Q is equal to 6,809 joules. For letter C, your work is from 3 to 1. So we're going from 3 to 1 along this path here. So we know that work is equal to the integral from state 3 to state 1 of P dV. Yung V natin at state 3, this is equal to 44.8, and at state 1, it is 22.4. Putting this expression back here, we'll get 44.8, 22.4, 6.643 times 10 to the negative 4, V squared plus 0.6667 dV. Integrating this one, we'll get that this is equal to negative 3,278 joules. So ito, kaya ng calculator nyo gawin or kaya ng mga equation solver natin. So this is your work. To get heat, we can get first internal energy. Delta U again is equal to N CV delta T. N CV delta T, or equal to N, which is 1. CV is 1.5 times 8.314. Delta T is 273 minus 1,092. And delta U will be equal to negative 10,214 joules. Getting Q from that, Q is equal to delta U plus W is equal to negative 10,214 joules plus negative 3,278 joules. Q is equal to negative 13,492 joules. And to know if our solution is correct or not, one way we can see is dapat in a cycle, the work and heat effects, or the sum of the work, is equal to the sum of the heat. Work, the sum of the work would be equal to 2,270 plus 0 plus negative 3,278. This is equal to negative 1,008 joules. For heat, adding the heat together, 5,675 plus 6,809 minus 1,3,492, equaling all that, get negative 1,008 joules. Since both are the same, we have a fairly certain parang medyo malalaman natin ba baka tama nga yung sagot natin. So for the heat and work effects, we have 2,270 and 5,675 joules for work and heat for process 1 to 2. For process 2 to 3, work is 0, Q is 6,809 joules. And for process 3 back to 1, you have work is negative 3,278 joules and Q is equal to negative 1,3492 or 13,492 joules. So hope you understood that, and if you have any questions, you can always ask me. Thank you.